All right, we are live.
All right, so I'm going to be the one taking question 1. So question 1, suppose a eukaryotic messenger RNA has the following nucleotide sequence. So the question A is asking which end of the mRNA molecule is the 5' end and which is the 3' end. So I just put them, as you can see right here. It's just the same thing. I just put the 3' end on the left and the 5' end on the right. And then for B, what is the sequence of the template of DNA strand? So basically, you just change U to A, C to G, G to C, and then T to A. I think that's what I did. Yeah, I might be a little wrong. I'm looking at it. And just flip it around. And that's what I did for B. And then for C, you just take A out and change it to T, and then that's where you get the coding strand. And there it is right there. And you flip it back to 3' to 5'. Now, hopefully you can see my little picture. So I drew it out, what it's asking. Draw the image that shows the 3 nucleic acid strands above during the elongation stage of transcription. And so we have the ta-ta box right here. The template strand is the 3' end strand. And the coding strand is the 5' end. And then we have the 5' attaching here, elongation. That's pretty much it.
All right. Question 2 is me. That is not question 2. Going back, one moment. There we go. Okay, so basically you read the instructor notes. You should be able to get your answers. And so, make that a little bigger. Okay. So the TATA binding protein binds directly to the TATA box, while the helix turn helix motif binds directly to the -10, -35 sequence. Guanylyl transferase is the eukaryotic enzyme. Group 1 introns use nucleoside guanosine as a cofactor, and group 2 introns use adenine as a cofactor. E is CPCF is the endonuclease that assists in terminating transcription. General transcription factors. The TF11B is the one that acts as a bridge subunit to link TF11D to TF11F /RNA polymerase II. TF11H is the one that acts to phosphorylate and activate RNA polymerase II. The small nuclear ribonucleoproteins, or SNRPs, is the spliceosome. These are the subunits that make up the spliceosome. And the spliceosome is composed of proteins and small nuclear RNAs.
Okay, and I'm taking question 3. Question 3, it can get a little tricky. Just really look through the instructor's notes and it should be clarified. Just remember what the differences between eukaryote and prokaryote are, and that'll between what proteins go to them. So for A, indicate 2 proteins in either prokaryote or eukaryote that act as helicase to separate the 2 DNA strands during transcription. I got 2F11H, which is the eukaryote, and then for prokaryote, I got RNA polymerase. B, indicate 1 protein in prokaryote that acts as a helicase to separate RNA from DNA during transcription, and I got Rho P protein. For C, that one was a little tricky. It said indicate 3 molecules in eukaryote that function during RNA modification as ribosomes. So there's catalytic pre-mRNAs, which is both group 1 and 2 introns, which can work as 2 of those 3 molecules, and then small nuclear ribonucleoproteins, which is the SNRPs. That's a tongue twister. And so there's your 3 molecules right there. Okay, and then D, indicate one protein and prokaryotes that act as transcription factor, and we got sigma factor. Okay, E, for the life of us, we could not figure it out. This is the closest we got, so if anybody else has figured this out or anybody else knows what the answer to E is, please let us know. We thought it was reverse transcriptase. Hopefully it's right. I don't know. It was hard to find. But yeah, that was question 3.
All right, question 4. Yes. So we have a pre-mRNA that is attaching to our YFG gene, and it has 4 introns. So my green lines are the introns, the purple is my DNA, and the red is the mRNA. So here you see that the coding strand, this upper strand, kind of bubbles out from where the pre-mRNA is linked, what's the word? It's something right there. Linked is my word, to the template strand. And so that creates an R loop. So then in B, you have a mature mRNA that attaches to your template. And since it's mature, it doesn't have introns. So these intron sections loop out from where it's linking. And so those are your intron loops, and then you have your R loops, which is where the coding strand didn't exactly, like, it has nothing, so it just kind of free for all.
That's pretty much a good way to describe it.
Pretty much, like, it's just floating around. So in C, it's asking the mature mRNA for YFG is hybridized, blah, blah, blah. In this case, the 5 most intron in the pre-mRNA, so that's this one over here to our right. You can see my little 5 prime. It was defected, has a defective donor site and branch site adenine. So I took that to be that it could not be cut out like it was supposed to, like the rest of the mRNA. So while the mature part, the one without these 3 different sections of intron, were able to attach properly, with the intron bases looping out and your R right there, R loops, that this one makes kind of like the first one where it just kind of loops out and there's an R loop. And so then part D is pretty much the same, but the 2nd and 4th introns in this case in the 5' to 3' direction. So here's my 2nd intron and here's my 4th, doing the same thing that happened in C. They didn't get cut out, so they're just defective.
All right. My turn. Okay, so question 5. Okay, so below is a list of proteins and nucleic acid sequence involved in transcription and RNA modification. So again, we just were careful and went back and referred to the instructor's notes. So if there's anything different, let us know. So which of the above is found in the bacterium of I can't say that. It's E. coli.
E. coli.
So we found that it was rut and -35 and nusa. That's how you pronounce that.
Yes.
Which of the above is found in the yeast? And then that word. -25 is what we got. Enhancer, silencer, group 1 intron, not group 2, just 1. The GC box, TF11D, and then SNRPs. Which of the above is involved in transcription initiation? That was just -35 and TF11D. Which of the above is involved in the transcription termination? And that is RUT and NUSA. Which of the above is a DNA sequence? We almost forgot to add one of these. So -25, -35, enhancer, silencer, and the one we almost forgot, which was GC box. You can't forget that in a DNA sequence. All right.
All right.